We've looked at how to find trig functions for acute angles by looking at a triangle with that angle as one of the angles of the triangle. If I take an angle in standard position, I can connect the two rays of the angle at a 90 degrees so that I do have a triangle whose side length here is given by x, the side length here is given by y. This could be the radius of the circle. We could denote it by r, where r is equal to the square root of x squared plus y squared using the Pythagorean theorem. And then that would give us this angle here and the trig functions of this particular angle. But we can actually do this for any size angle. If we have an angle in the second quadrant, we draw a vertical bar to the x-axis that is perpendicular. And now this is given by the x and y. So we can find the trig functions based on this. If our angle lies in the third quadrant, we once again draw a vertical line to the x-axis. And now this side is x and this is y. And we can find the trig functions of this angle. Finally, if my angle is in the fourth quadrant, I draw a vertical line to intersect the x-axis, and I have x and y. And we can actually use all of these to redefine our trig functions. So for instance, sine of theta is always going to be y over r. Cosine theta is x over r. And tangent theta is y over x, provided x is not equal to 0. And then we can use these to define the other functions, the cosecant, secant, and cotangent. So let's look at some examples. I want to find sine theta, cosine theta, and tangent theta if the terminal side of theta passes through the point -1, 2. So this is what it looks like graphically. This is an angle in the second quadrant. We always draw a vertical perpendicular to the x-axis. We know that x is -1 and y is 2. And we know that r is equal to x squared plus y squared, and then the square root of that. So this is the square root of 5. So then if I want to find sine of theta, I'm going to use opposite over hypotenuse, 2 over the square root of 5. I can multiply the top and the bottom by the square root of 5 to get 2 square root of 5 over 5. For cosine of theta, we look at adjacent over hypotenuse, which means -1 over the square root of 5. Or if I multiply the top and the bottom by the square root of 5, negative square root of 5 over 5. Finally, tangent is opposite, which is 2 over adjacent, which is -1, or -2. Now let's find sine, cosine, and tangent if the terminal side passes through -3, -2. -3, -2 is in the third quadrant, so this would be an angle in the third quadrant. We draw the vertical perpendicular to the x-axis. We know that x is -3 and y is -2. So r is the square root of -3 squared plus -2 squared, which if we work this out, we get the square root of 13. So sine of theta is going to be opposite over hypotenuse, so -2 over the square root of 13. We can multiply by the square root of 13 over 13 to get -2 square root of 13 over 13. For cosine of theta, we need adjacent over hypotenuse, so negative 3 over the square root of 13. We multiply by the square root of 13 over the square root of 13 to get negative 3 square root of 13 over 13. Finally, tangent of theta. This is opposite over adjacent, so negative 2 over negative 3, or 2/3. Let's do one more, this time through the point 3, negative 1. In this case, our angle lies in the fourth quadrant. We would draw our vertical bar. X is equal to 3 and y is equal to negative 1. R is the square root of 3 squared plus negative 1 squared, which is equal to the square root of 10. To find sine of theta, we use opposite over hypotenuse. The opposite is negative 1 and the hypotenuse is the square root of 10. We rationalize our denominator to get negative square root of 10 over 10. For cosine of theta, we use adjacent, which is 3, over the hypotenuse, which is square root of 10. And we rationalize our denominator to get 3 square root of 10 over 10. Finally, tangent of theta is equal to opposite over adjacent, so negative 1 over 3, negative 1/3.